Hello class, so today we're going to be looking at three different examples of how to solve square roots and squares of rational numbers. So in this example here, it says calculate the number whose square root is provided here 3 over 8 and 1.8. So this here is the square root. So what we're looking for is the square. So we're going to look at 3 over 8 squared. And to do that, you can say 3 over 8 squared is the same as 3 squared over 8 squared, or 3 times 3 over 8 times 8, which will give us 9 over 64. And the next example, B, we have 1.8. So this one here, same work. So we're working with the decimal. You might need a calculator for this one here. So 1.8 squared is the same as 1.8 times 1.8, which would give us 324, 3.24. Okay, so what this is, so 3.24, the square root of that is 1.8, and the square root of 9 over 64 is 3 over 8. So let's look at another example here. So here, the question is each fraction a perfect square? Explain your reasoning. So pay attention to what explain your reasoning means, or showing the work for this kind of problem, and we are going to see this in assessments. So if you have 8 over 18, this one here, a lot of people would say, well, if you're looking at the square root of 8 over the square root of 18, that's not going to work. However, make sure that you check for another thing. So what you are going to look at is 8 and 18 are both divisible by 2. So that would give us 4 over 9. And 4 is a perfect square, and 9 is also a perfect square. So if you want to take that, the square root of those two numbers, you're going to end up with 2 over 3, or you can say 4 is equal to 2 times 2, and 9 is equal to 3 times 3. So either one of those two ways would be a solution for this problem. So this would be a perfect square. What about 16 over 5? So 16 is 4 by 4. 5 is a prime number, so really 5 does not have any factors. So this one here is not a perfect square. Because 16 is equal to 4 over 4, but 5 does not have any two rational numbers multiplied together that would give you 5. Okay, so that's not a perfect square. Same thing, C, also not a perfect square, because 2 is another prime number, but 9 is. So 9 is equal to 3 times 3, but 2 does not have any two, again, rational numbers multiplied together that would give us 2. And the final example we're going to look at is something here with decimals. So is each decimal a perfect square? Explain your answer. So 6.25. So with decimals, you want to write it as a fraction first. So 625 over 100 is a good way to look at it, because you want at the bottom to have even number of zeros, because if you have an odd number of zeros, that is not a square. So if you look at 10, the square root of 10 is irrational or not rational number. Square root of 100 is 10. Square root of 1000, if you use a calculator, that's also not going to be a rational number, the square root of 10,000 is 100. So that is a hint on what you need to use to solve these problems. So let's look at, so this one here, 625. 625 is the same as 25 times 25, and 100 is the same as 10 times 10. So this one here is a perfect square. What about the part B? So this one here is 627 over 1000. So neither the top or the bottom have two factors that multiply to give you 627 or 1000. You can look at this because 625 is 25 times 25. So if you go one up, you're gonna go way over 627. If you go one down, obviously you're gonna go down. So this one here, you can also check with a calculator. So square root of 627 is irrational. This also the square root of 1000 is also irrational. So this one is not going to be a perfect square.